All right, we can start. So let's take a look at the first problem here. Again, I'll just give you a little bit of time to see, take a look at it, try to solve it on your own. This one I'm actually going to go over two different ways. There's a way to kind of do it straightforward, and then there's another kind of quick way to do it in Desmos. If you can't completely see it, I'll just rewrite it here. Okay, so this is an equivalent expression problem. So one way to go about this is to kind of try to simplify both sides. So on this side, we can divide each of these by 4. It's kind of like the opposite of common denominator. So we're going to do 12x over 4, which is 3x, and then 28 over 4, which is 7. So you got 3x plus 7 minus this s over 13 equals. And then on this side, I can distribute. So if I distribute the r, I get rx minus 8r. I want you to look at this equation. We've got two different parts. One part is where the variable is. So on one side we have 3x, and on the other side we have rx. And then the other part of each of these is what we would call the constant, so the part that's not the variable. On this side, it's this whole thing. It's 7 minus s over 13. And on this side, it's negative 8r. So in order to have an infinitely many solutions, everything on each side of the equation has to be exactly the same. So this tells me right away that r must equal 3. Because if I have an rx and a 3x, I need them both to be 3x, so r would then have to be 3. And then what I also need is for the constants to equal each other. So I need the constant on this side, which is 7 minus s over 13, to equal the constant on this side, which is negative 8r. But now that I know r is 3, that's negative 24. And then I'm just going to solve this equation. So I would subtract 7 from each side. So I get negative s over 13 is negative 24 minus 7 is negative 31. And then I could just multiply each side by negative 13. So I get s equals, it's really going to be 13 times 31, which is 403. So the value of s is going to be 403, and r would be 3. And if that's true, then the left side will equal the right side, which is again what we're in search of when there's an infinite number of solutions. Any questions on the way I did it that way? Because there is a quicker way, so I want to go over that as well. But the
No,
concepts are super important.
makes sense.
Okay. So again, the concepts are always important. But sometimes there's like a quicker way to do Desmos. We were talking about this last week, and this is actually a great example of how we can do this. So when you have an equivalent expressions problem, in this case, I mean it's an equation, but it's kind of like equivalent expressions. Um, and you have these constants, so we have R and S. And when you have a single variable like X, then sometimes you can do it in Desmos using this thing called regression. So I'm going to show you that because this can definitely save you some time. So the way it works is you type in the equation again, but instead of X, whatever the variable is, you use like you put X sub 1. The way you do it in Desmos is literally just type X1 and it'll automatically show up like this. All right, so I have this, and then I'm doing minus S over 13. So all I did was I typed the left side of the equation exactly as is, just with an X sub 1 instead of X. And then I put this little like it's like a tilde or this little squiggly symbol. All right. And you put that in, and then you put the right side. So R parentheses But now, again, I got to do x1 instead of just x minus 8. So right now, it has the wrong answers. So that's really important because its default is to just plug in at the for the variable 1 and just give values that work. But if Desmos only plugs in one value for the variable, then there's two unknowns. So then there's not just like we need we need more values to plug in to actually figure out what S and R is. So what you do is you go down here and you write x1 equals, you make a little bracket, and then you just put in a couple values. So what I usually do is however many constants there are. So in this case, we have R and S. I can put in two values. You can always just put in more to be safe. But if I notice what happens when I plug in, say 1, comma 2, it tells us right here that the answer for S is 403 and R is 3, which we figured out as well. But the question specifically asked for S. So this is a type of regression that you can use for certain equivalent expression problems, which clearly most of me doing this was explaining. If I just did this, it would take me like, 20 seconds, as opposed to the other way would have been a little bit longer.
All right.
Cool. Thank you.
Yeah, you're welcome. Yeah. So this is pretty cool. It's you got to be careful though. I think we had one last week where there was like X and Y, and then it gets a little bit tricky. I really like this when and also what I was saying before, if you're really concerned with like how many values should you put in this thing down here, like notice if I just keep going, it doesn't change the answers. So just put in a bunch if you're concerned. Um, but yeah, it works well with just constants and one variable. Okay, again, the R and the S are called constants, and the X is variable. And whatever the variable is, you got to put this little one because if I get rid of that one, then it Desmos doesn't recognize what it's even doing and doesn't work. But if you want to graph something, then you want to just use the X. Let's keep going. So let's try the second one. Okay. This one I'm only going to do in Desmos, but I will talk about kind of why. And we have to do one quick thing before we would even use Desmos. Um, so the first thing here is to recognize what K has to equal. There are some problems where when the setup looks like this, you can make K anything you want, but this is not one of them because they specifically tell us, whoops, that I thought I was on the drawing here. They specifically tell us that the y-intercept is this point. And we should know that y-intercepts are always when the x value is equal to 0. So this means that k has to equal 5. So no matter which way you attack this problem, that first part we all have to get. All right, so we really need that k is equal to 5. So that's the first part of this. All right. Now, once we know that, we have a couple of options. So we know that this is now 5, and then this one is 12, because 5 plus 7 is 12. And now, what I think would be the long way would be to find the slope and then plug in one of the points to find the y-intercept to like y equals mx plus b, because that's b right here. They're just asking for that, which is the y-intercept. Okay. Again, what I think is quicker is let me just hop over to Desmos.
Exit 13.
I don't believe so because the point is 5 comma 13. So it wants to know the y-intercept, which is when the input is 0. But I think I know where you're getting that. I'll explain that in a second. So what you do is you just insert a table and you do 5 comma 13 and 12 negative 15. And then you hit regression. and then it just gives you the equation, and the y-intercept of that equation is 33.
Right, because that's what 'cause that's where it intersects with the y-axis.
Yeah, yeah. I mean, and we could like find it here as well, but you don't even like once you have the equation, if you know slope intercept form, then yeah, that b value is the y-intercept. So once they give us the equation, we know the y-intercept is 33. Um, so b is just 33. Yeah, so again, there's a difference between k being 5 and x being 5. So they wanted the y-intercept, which is really when x is 0. All right, so that's why the answer wasn't just 13. We were looking for what when x is 0, what's the value of y? Okay. Here we got a word problem, which is another one that I think I'm going to use Desmos, but just give it a shot first. Okay. So here I'm just going to write out the information they give us. So if the bin contained 24,000 when he began, that's like the coordinate 0, comma 24,000. And then after 5 hours, 19,350 remained. And then it says, what is the total number of hours that he'd been using it when that many remained? So it's kind of like, what is the this amount when you have 12,840 left? And this is just a linear equation problem. So again, it's up to you. You can, one option is to find the slope, come up with the equation, which this is the y-intercept. So it would be just the slope times x plus 24,000, and then set it equal to 12,840 because this is the y, and then solve for just the missing x. So everything that I kind of laid out can take a bit of time. So what I'm going to do is show you just how we can do this quickly in Desmos. And let me do that real quick. Okay, so again, the word problem just laid out these 2 points and wants to know the x value when we have this value as our y value. So what you can do, again, to probably save time over doing it the long way, is create another table. And in that table, I'm going to put 0, 24,000. And then I'm going to put 5, 19, 350. And then it's gonna give me the regression equation. Okay, or just in this case, it's 2 points, so that's the equation of the line. All right, so we get the equation pretty quickly. Now what we can do is we can just graph y equals 12,840, and that should give us a vertical line. I'm going to need to zoom out a lot. So this is turning out to possibly not be a great idea. Um, no, it worked. Um, so what I did was I graphed the y value, which is a horizontal line, and then this is finding the intersection with the line that we just graphed, which is the other 2 points. So this just tells me that the x coordinate was 12, so that would just mean after 12 hours there would be this much left. So I th sometimes with really big numbers, Desmos isn't the best option, but I just kind of took a chance, and it did work out. It gave me the intersection, so that means when I hop back to the problem. It just means that after 12 hours, there would be this much remaining. And like I said, there is the other way of doing it, which all those concepts you need to know, find slope, plug in the y equals mx plus b, set equal, and solve. Um, but that could be just a pretty quick way to do it in Desmos. So then I got some requests to do quadratics. So a lot of the problems that we're going to do for the rest of the time are going to be related to different sort of questions involving quadratics. So this one, I'll give you a little bit of time to do it. This one's a pretty tough problem. Okay. Um, this one is pretty tough. I think we did one like this a couple weeks ago. But this is a different problem. And in these hard problems, they expect you to put a couple concepts together. So one thing is that if we have this vertex, 7 comma 12, that's in the first quadrant. And if this parabola is going to have a vertex in the first quadrant and intersect the x-axis at 2 points, then it must be a parabola that opens downward. So one of the keys to this problem is knowing kind of right away that a has to be less than 0. All right. This a value, which that a value shows up in all three forms, is when it's positive, it's a parabola that opens up, and when it's negative, it's a parabola that opens down. Okay. So that is the point of them giving us this thing that says it has to intersect in 2 points. Then what I would do is kind of turn it into an equivalent expressions problem a little bit. So we have this form, which is standard form, but they give us the vertex. So if I wrote it in vertex form, that would be x minus a times x minus 7 squared plus 12. So this is true just based off of them saying that it can be written in standard form, which obviously every parabola can be written in standard form. And then if they give me the specific vertex, I can plug that into vertex form. And it represents the same parabola, so I know these are equal to each other. So now I have a couple of options. There is a way to use Desmos. People showed me the last time I did a problem like this, how like I saw some screenshots of Desmos. I didn't really think that was any faster than the way that I did it. So if you certainly find a way to use Desmos, that's totally fine. Um, but I thought it was still just as complicated. And so what I would do is I think the trick here is that if you have equivalent expressions, we saw earlier one option is Desmos to do the whole like X1 regression thing. Another shortcut option you have is to just choose a value for X. And the left side has to equal the right side because they're equivalent expressions. So they should be equal for all values of X. And in some problems where you choose your own value, there's a lot of different values that can work. In this problem, there's one value that really, really makes the most sense, and that is just making x1. And that's because if I make x1, then this is A, then this is B, and this is C. And they're asking me which could be the value of A plus B plus C. So by picking one, I've automatically got the thing that they're looking for. Now on the other side, 1 minus 7 is negative 6 squared is 36, so I get 36a plus 12. And then it says which could be the value of a plus b plus c. Well, now I'm going to just check my answers. So imagine it was 10. And this is the only one I'm going to even write out this way. So if I solved for a, I'd subtract 2. Or sorry, I'd subtract 12 and get negative 2, and I'd divide by 36, and I would get a value of a that were negative. Well, that's what we figured out in the beginning is that a has to be negative. And if you look at the other answers, like imagine I replace this with 14 because it's imagine a plus b plus c were 14. Well, 14 minus 12 is positive, and then I divide by 36, that's positive. And that's going to happen when with all of these answers. You're going to get a positive value of a, but that contradicts this whole thing with it crossing the x-axis twice. So the answer ends up being a because it's the only one that'll give me a positive, or sorry, a negative value for a. And even if you use Desmos, you'd still that kind of line of thinking you have to do in this problem because it's there's not a definitive answer. It's just what could it be. So of our four answers, only A would make sense. But it's a pretty tough problem. The long way is to like expand this right side out, and that takes quite a bit of work. Um, And then when you combine like all what A, B, and C are, you end up getting 36A plus 12 anyway, and you have to still do that same line of thinking. So this making X1 is just a little bit of a shortcut. All right, let's move on. Okay, this is one where I would definitely say Desmos is the way to go. Okay, so I'm actually just going to do this entire problem in Desmos. I'm going to show you how to do that. There are certain steps that I'm going to do that you might be able to then just do by hand. I don't know if that'll be any quicker or not, but I just want to kind of take you through a problem that you literally could just, the entire thing could be done in Desmos. So okay, so the first thing is we're given a table, and they mentioned it's a quadratic. So make if it were a linear table, I would only pick two of the points. I wouldn't even waste time with the third point. But since it's a quadratic, we really need all 3 points. So we have 14, 35, then it was 16, 21, and then it was 18, 35. And then I do regression. This one, the default. Oh, let me change that. The default is linear, so we're going to have to change it to quadratic. And then it says y equals this. But again, I'm going to do it just so the whole thing is in Desmos. So I'm just going to do f of x, and then I'm just going to retype that real quick. So 3.5 x squared minus 112x plus 917. And then they want g of x to equal f of x minus 371. Um, I want these to be lowercase. I accidentally hit caps locks. Okay, now we're back, and then finally just g of 0, and the answer is 546. Now that is just a way to just if like literally do the whole thing in Desmos. Some shortcuts might be well, actually, first of all, make just realize like we had this y equals this, but I needed it to be f of x so that g of x could be based off of f of x. That's like why I retyped it here. But that could be wasting time. If we know that g of 0 is just the y-intercept and the y-intercept of this is 917, then we could probably just stop there in Desmos and just do 917 minus 371, and that would give us our answer as well. But again, just to kind of take you through how you could literally do every one of these actions in Desmos and it'll just lead you to the answer. Okay, let me just write the answer for that one. So it was 546. Okay, tried this one. This is one where you could use a Desmos slider, but actually I find it easier to just do it by hand. So just take a minute to try that. Okay, so this is one where if you wanted to use Desmos, you could, you just have to know that a 0 is an x-intercept. You just graph this and you make a slider and you try each answer and then you just look at the graph and see which one crosses -5 on the x-axis. And it's a fine way to do it, but I just find it if you can do math pretty quickly, then I feel like the other way you can do it more quickly. So if -5 is a zero, all that means is that when x equals -5, the entire function equals zero. So you are just writing zero equals. And then if you could do some of the math in your head, like when you plug in -5, instead of having write -5 squared, if you just know that that's 25, and then when I replace x with -5, this is minus -5, so you just get plus 5a plus 15. And then if you could just really quickly do 25 and 15 is 40, and when I bring it to the other side, I get -40. And then stop there and realize that if I divide each side by 5, a has to be -8. To me, if you could do a couple steps at a time, then this is definitely probably quicker than having to type it into Desmos and then change each answer and realize that it's just the last one. But if for some reason you have difficulty or you're worried about making a silly mistake, then just use Desmos with the slider, and you'll see that when a is -8, you in fact will get -5 as an x-intercept. Okay. Which one has no solution? Again, I'll give you time. You can definitely use Desmos, but like I think that you could do this more quickly without Desmos and even without a calculator, but just give you a minute to try that. Okay. So I'm going to do this one by hand, but if you choose Desmos, it's totally fine. The downside of that is you may have to plug all of them in, which I think in this one you end up having to do because it's D, um, which could take a little bit of time. But if you just commit to that immediately, it's not too bad. But again, the you have to realize what you're looking for. So in the Desmos way, you just make sure you're looking for a parabola that has no x-intercept, so it just doesn't cross the x-axis. Um, so that's important. But the other way is the discriminant. And the discriminant, there are ways for them to ask the problems where Desmos is not really an option. So it's good to just go over this anyway. You should know the discriminant regardless of if you plan on using Desmos a lot or not. Um, when there's no solutions, the discriminant, this b squared minus 4ac, is going to be less than zero because it's the thing that's under the radical. And if you're taking the square root of a negative, you won't have any real solutions. So that's why that is. And what you can realize is that every one of them has a b of 14 or -14. And it doesn't really matter um, whether it's negative or positive because it's going to get squared, and 14 squared is 196. So like right away you get 196 minus 4. Now A and C are a little bit different. Well, look at answer choice A and C. You're going to be subtracting a negative. So those are just going to be adding and are not going to be less than 0. So those are just out automatically. And then when I'm down to two choices, I only need to check one. Um, and then I realize that in both of them, I'm going to be multiplying by 49. So it's probably the one with the 5. So I'll check that so that it makes this thing bigger. And that, in fact, is negative because 4 times 5 times 49 is going to be bigger than 196. And when you subtract them, you're going to get a negative. So there is a way to just like kind of do that quickly without needing to do very much in the calculator. But again, I'm not opposed to the Desmos way there. Just wanted to offer another way and go over the discriminant really quickly.
All right.
All right. I got D too. But yeah, I use Desmos. So.
Yeah, Desmos is fine there. The only issue is if your kind of mentality is like I'm going to always use Desmos on these problems, I've seen discriminant problems where Desmos is just um, either not possible or really, really much longer. So the discriminant is a good thing to know, but also when you do use Desmos, knowing what you're looking for is super important as well. So none of this is a shortcut for like knowing any less math. All right, here we go. This is another discriminant one. I think this is an example of what I was talking about. I think Desmos would be tough here, but let's see. So let's take a minute. Okay, so anytime that they're talking about the types of solutions to a quadratic specifically, they're referencing the discriminant. And sometimes, again, like in the last problem, we could, if we wanted to, bypass the discriminant and just look at the graph. This one is a little more complicated. Because there's no multiple choice. So if we had four answers, certainly we could use a slider and just plug them all in for A and see which one like gives us no solution. That's kind of difficult here, especially once you see the answer. I doubt that you're going to just guess that in Desmos. Definitely not more quickly than I think we could do it by hand. So this is why it's really important to like know the concepts and be able to use Desmos in the opportune times. So what I do is again, I read the problem, I see types of solutions to a quadratic, and it's open-ended, so I'm just going to be committed to the discriminant. And I've got my b squared, so that's 30 squared, so I got 900 minus 4 times a, well, a is a, times negative 9 has to be less than 0. All right, so we've got no real solutions, discriminants less than 0. Now the problem becomes a little easier. I just want to make it look like this. All right, so there's this random k in there. Don't worry about k yet. Just take what you already have, whatever thing got you started, and just make it look like this, which means I want this a to be by itself. So I get 900. Well, negative times negative is a positive, so I get plus 36a is less than 0. Then I'm going to have 36a is less than, I'm going to subtract the 900, so I get negative 900. And finally, I get a is less than, so when I divide these, I get a is less than negative 25. So now when I just match these up, I can clearly see that k, the value of k, must just be negative 25. So that's my answer. So discriminant, and then just make it look like the inequality that they have, and so the number on the other side must be k. All right, let's see. We'll do either one or two more. Let's see how much time we got. So let's try this one. Okay. So, um, so what I'm going to do first, so we've got this vertex here. So I'm just going to start with vertex form. So we need a place to get started. So vertex form is going to look like this. And then I am going to try to simplify that. So I have a, and then I have x squared plus 10x plus 25, and then minus 100. And then I'll just distribute the a. So I get ax squared plus 10ax plus 25a minus 100. All right. So then So I'm kind of taking you through. I mean, there could be another way of doing this, but I'm actually looking at this problem for the first time. So I'm just kind of showing you my thinking. It's all right. They give me the vertex, so I start a vertex form. Then I can expand it. Now I'm going to match it up with what it says here. So I have ax squared plus bx plus c. All right. So this tells me that A is obviously A. That's not really helpful. I have this relationship that 10A would have to equal B because that's the coefficient of X. And then I have this relationship. This is the constant, that 25A minus 100. That has to equal C. That's the key because then it says, then I go back to the problem and like, well, what else is it talking about? Well, the thing I haven't used yet is that C has to be greater than zero. Well, if C has to be greater than zero, then A would have to be bigger than four. Because if A were four, 25 times four is 100, 100 minus 100 would be zero. So I know that A is bigger than four. Then if A is bigger than four, well, I need to, then A, first of all, B isn't going to be negative. B has to, the only possible value that's here is for B to be 60. Because if A is bigger than 4, then B could be 60. It can't be 40 because then A would have to equal 4. And if it were negative 40 or negative 60, then A would have to be negative. But we've already established that A has to be bigger than 4. All right, so there might be a quicker way to do that problem than what I just did, but I honestly was a little bit confused in the very beginning. So I just kept kind of working through all the possible things and just like matching things up. And it eventually kind of made sense that D is the only one of these answers that would work. Okay, so are we all good with that? Okay. Yeah, that's a super hard one. Um, okay, I think we're gonna stop there. So, again, as always, I'll email this week with the notes and the link to the YouTube video, and then just during the week or up to next week, just send me problems, and next Monday we'll go over whatever problems or topics that you want to go over.
All right.
I got it. See you next week.
All right, see everybody
See
next
you
week.
next
Thanks for
week.
coming.
Thank you.
Next week.